when I'm not giving you all these things, then you should give me out of out. That's what I
Yeah.
believe in. Isn't
But
it
we are
better?
trying to give you out of out and yeah.
But I fail to get. That is the problem. So this time at least make me happy. I want
Yeah,
all
ma'am,
of you.
sure. Yeah.
Thank you, beta. Thank you. Okay, good morning once again.
Good morning, ma'am.
Good morning,
Good
ma'am.
morning, ma'am.
So now we are going to continue with the same. We talked about in the first lecture regarding the tectonic plates, the movements of tectonic plates, which creates or which generates or which develops earthquakes, right? Now these earthquakes could be under the earth or could be under the ocean. When it's under the earth, we get the tremors or the shivers, which is called as earthquake. When it is under the ocean, the name comes as tsunamis. This is what you should understand. Is it clear?
Yes, ma'am.
Yes. Okay. So tsunami is also an earthquake, but it is under the ocean. Now see over here the movements of earth plates. In this case, there are two plates. Can you see two plates better? This is one
Yes.
plate, and this is the second plate. Can you see this?
Yes.
Yes.
This plate and this plate is colliding. Can you see the arrow what I have shown you?
Yes.
Yes.
Okay. These two plates are colliding. What is the meaning of collision? They are colliding.
Like,
They're banging onto each other.
yes.
So, what is developed? Earthquakes. This is one. Secondly, it is brushing past. One is moving this direction and one is moving the other direction. You got it? So, see, you can see over here, it is brushing past. Can you see over here?
Yes.
Yes, it is
Yes.
moving on that direction, this is moving here. So, that also develops earthquake. Understood better?
Yes.
Yes.
Now, what are the areas where you get earthquake? These areas are called as seismic zones. What are they called as, beta? Seismic zones. Where,
Zones.
where
Seismic
that is
zone.
earthquake prone areas. What are they? Earthquake prone areas. That means that means you get more of earthquake in these particular localities. That's why these are called as seismic zones or fault zones. Please start.
The
The
seismic
seismic
zones in
zones in
India.
India are Kashmir, Himalayas, Indo-Gangetic
Gangetic.
Plain,
Gangetic. Who wanted to
Gangetic
read?
Plain.
Delisha, just hold on. Someone else wanted to read. Who is she?
Ma'am, Shifa
Ma'am
Dabang.
Shifa.
Shifa. Let Shifa continue better. Okay, if you
Okay,
don't
ma'am.
mind. Delisha, if
Yes.
you don't mind. Fine. Shifa, begin better.
Yes, ma'am. The seismic zones in India are Kashmir, Himalayas, Indo-Gangetic Plain, Northeastern Region, Kutch, Rajasthan, Andaman and Nicobar Islands, some regions of South India, etc. The power of an earthquake is measured on a scale called Richter scale. Very destructive earthquakes have magnitudes more than 7.5 on the Richter scale. Earthquakes produce waves on the surface of the earth called seismic waves. Seismic waves are recorded by an instrument called seismograph.
Understood? So, what are the seismic zones? What are these fault zones? What are these zones where you find earthquake now and then? They are Kashmir, Himalayas, Indo-Gangetic Plain, northeastern region. Now, what is northeastern region? Assam, Arunachal Pradesh. So these are the northeastern region. Kutch in Gujarat, you know that. Rajasthan, Andaman and Nicobar Islands, and certain regions of South India, you get this earthquake. How do you measure this earthquake, by the way? There is a scale which is called as Richter scale. So with the help of Richter scale, we measure the earthquake. If the earthquake is more than 7.5 Richter scale, then it is very, very destructive. Generally, we know that earthquakes it produce waves on the surface of the earth, which are known as seismic waves. What are they known as? Seismic waves.
Seismic
And these seismic waves are recorded by a device or an instrument which is known as seismograph. Have you understood the whole thing?
Yes.
Yes? Okay. The intensity of earthquake is measured by Richter scale. Seismic waves or earthquake is recorded by seismograph. Please understand both the things. The intensity is measured by Richter scale. The earthquake is recorded by seismograph. Have you understood?
Yes.
Girls,
Yes.
have you understood? Why only
Yes.
one and two yeses? There are 12 people, I think so.
No, ma'am.
No,
Now it
ma'am. Now it's
become
become 9.
9.
9. Okay, so at least 9 yeses? Doesn't matter. At least 9 yeses, if they understand. So,
Yes.
rest of you have understood what I said? That
Yes.
earthquake, the power is measured by Richter scale, but it is recorded by seismograph. You understand? Both are different. Yes? Okay. Look over here. This is the Himalayan zone. You see this? This is the Himalayan zone.
Yes.
Here you get most of the earthquake. Then you got the Gangetic plain, this one. Here also you can get earthquake. Then here is Andaman Nicobar in the Indian Ocean. There also you get. Then Kutch over here, Rajasthan here. So all these are the places of earthquakes. You can see over here there are lots of plates over here. All these broken lines are the areas of earthquake. You got it now? Because the plates are moving continuously. Can you see this better?
Yes.
All these are the places where earthquakes may happen because of plate movement. Okay? These are the areas where you can see uh, earthquakes. Let's talk about India. Let's see here. Srinagar. You see this plate?
Yes.
Then you have the Himalayas region. Can you see this region, Himalayas? Then you have the complete northeast, Shillong, Itanagar. Yes, beta. Then you have the Bhuj. Can you see this Bhuj over here? These are the prone areas. Got it? Over here you can see the zone 5. This is the pink color. You see this pink color? Is the most dangerous zone where you can see this one. See, Andaman Nicobar, Port Blair. You got it? That comes under zone 5.
Yeah.
Yes.
Yes. Here you get maximum earthquakes. How do you protect yourself from earthquake? Let's see. Please continue.
Protection from earthquakes. Number 1. The buildings in seismic zones should be designed such that they can withstand tremors due to earthquakes. Materials like mud, wood, and light roof should be used instead of heavy materials. Heavy objects like cupboards, water heaters, etc., should not be fixed on the wall. All buildings should have firefighting equipments.
Okay. Now, whatever you read just now, I'm just want to elaborate it. Wherever is the seismic zone, that means wherever you can have the prediction of earthquakes in future, if you are building any society or any houses, it should be designed in such a manner that they can tolerate, they can withstand the shivers or the tremors of earthquakes. You understood? So they should be made in a different manner. You understood? So there won't be much of loss due to earthquake. Secondly, what sort of materials should we use? You should use light materials like mud, wood, and light roof instead of heavy materials. Understood? Thirdly, cupboards, water heaters, these are heavy objects. You are not supposed to fix it on the wall because it may fall and there may be an accident. Lastly, all the buildings in these areas should have firefighting equipments because there are likelihood, there are chances that fire may break. Your house may catch fire. You understand?
Yes.
Yes.
Now, what are the precautions that you have to take during an earthquake? Please.
Precautions during an earthquake. A. If you are at home, take shelter under a table. If you are in bed, do not get up. Protect your head with a pillow. Stay away from tall and heavy objects which may fall on you.
That's
If
it.
you are
That's it.
outdoors,
Rita. That's it. Okay. Now, what are the precautions that you have to take during an earthquake? For instance, if you are at home, what you will do? If any table around, you will take shelter under a table. Secondly, if you are in bed, do not try to get up, but take a pillow and put it on your head. Also, if at all in the house there are tall and heavy objects and there are chances that they can fall on you, stay away from those objects. So these are the ways that you can take precautions at home. Now let's see what you can do if you are outdoors. Please.
if you are outdoors, find an open area away from buildings, trees, and power lines and lie on the ground. If you are in a car or bus, ask the driver to slow down and don't get out till the tremors stop.
So if you're outdoors, that means you're not in the house, what you will do? You'll go to an open area which is very away, which is far away from buildings, trees, or the lines, the power lines. You know what are the power lines? In between the electric poles, the lines, the cables which are stretched from one end to other end, they become loose and they start swaying. They start swaying from one end to other because it become loose. Stay away from them, and you better lie on the ground. And if at all you are traveling or in a car or a bus, then ask the driver to slow down the car or the bus and stay in the car, stay in the bus till the tremors stop, till the earthquake stops. This is how you have to take protection. So far, any problem?
No,
No,
ma'am.
ma'am.
This is what happens. See, this is the earthquake. Got
Yes.
it? This is how it
Yes.
looks like.
Yes.
This is the earthquake. See. You can see the light is on. Can you see the light is on?
Yes.
Because of this,
Yes.
sometimes the house catches fire. You know that? Because of the short circuit, the house
Yes.
catches fire. And what is this?
Landslide.
The road. The road is gone. Got it?
Yes.
Can you see the road is broken.
Yes.
Can you see over here? It's become all uneven. See how high it has come up. See, and this has come down. Again, this thing has gone down. This is flat. See, this is flat. But look at the condition over here. It is broken.
Yes.
And just look at this condition. Got it? It's all broken. Let's see how tsunamis work. You see over here,
Yes.
what has happened? Actually, this thing is supposed to be here, isn't it? What happened? It
Yes.
went up.
Up.
When it went up, look at the top. Here also it went up. See, it went up by here. It went also up by here. See, can you see this? This much. Yes.
Yes.
And when it this much a portion, this is one plate. This is the second plate. When the second plate went up, it is pushed up. Can you see the arrow? Can you see this arrow?
Yes.
This arrow has pushed the waves, the water also up. And when the water has gone up, a wave has been created, which is called a tsunami. You got it? This is tsunami. Got it?
Yes.
Yes.
Now see how this earthquake has happened. This is one plate, this is second plate. There is an impact, there is a force of one plate onto the second plate. Yes? And this is the epicenter of the earthquake. The earthquake started here. But the effect will be seen somewhere else. And this is the fault line. What it is, beta? Fault line. Where you have the likelihood of, because it is always moving, the plates are always moving. Sometime this plate has gone up, you can see the second plate has gone up. Sometime this plate may go up. Getting my point? Because it is continuously moving. And that's creating the earthquake. Any problem?
No,
No,
ma'am.
ma'am.
This is what you get. Huge waves during tsunami.
Tsunami. Yes.
Tsunami waves. Got it?
Yes.
Now let's see the device that is seismograph, which records earthquake. Please.
Seismograph. Earthquakes generate seismic waves which can be detected with a sensitive instrument called a seismograph. Advances in seismograph technology have increased our understanding of both earthquakes and the earth itself. Perhaps the earliest seismograph was invented in China AD 30
136.
136 by a man named Choco.
Okay. So earthquake is giving out which type of waves with the seismic waves. You agree? So
Yes.
earthquakes give out seismic waves, which is detected by which instrument? Which instrument is detecting earthquake beta? These seismic waves?
Seismograph.
Seismograph. Now people started working on this technology, working on the seismograph. So what we are trying to find out? We are trying to learn, study earthquakes as well as earth because earthquake and earth are related. The earliest seismograph was invented in China. China was very high in technology from the beginning. So earliest seismograph was invented in China, that is 136 after the death of Christ by a person named Choco. So Choco was the first person who had developed seismograph, ancient seismograph. This is how it looks like. See, it's a rotating drum. The drum keeps rotating. You see this? And this pendulum bob starts recording the earthquake. If the tremors are very high, that means it is destructive. If the tremors are only this much, that means the earthquake will not have much of destruction. Understood? More the tremor, more the destruction. Okay, beta?
Yes, ma'am.
Hello?
Yes,
This
ma'am.
is what is here? This is a bob, sort of pendulum, isn't it? Now, over here, can you see this? This one. That means the destruction is more. Earthquake on the Richter scale is going to show near about 7 or more than 7. So it is destructive. Whereas this one, can you see this one? This earthquake is okay. That means it will not show any destruction. Any problem? Only this portion will show maximum problems. You understood?
Yes, ma'am.
Okay. Are you finding any problem, beta?
No, ma'am.
No, ma'am.
This is same thing, the seismograph that you can observe. So we come to close of this chapter today. Do you want to ask me any question?
No.
No.
The chapter is over, beta. That is lesson number 15. Some natural phenomena. You have completed the chapter. Actually, I had taken so many slides repeatedly, so
Yes.
I just wanted to revise while doing the chapter. I hope you have understood the maximum. Do you find it difficult in any form?
No, ma'am.
We still have got 15 minutes. Can I start with a new chapter? Because I've started with boys and I've finished almost 16 slides today. Can I start with a new chapter that is, I'm asking your permission. Lesson number 16, that is light, because I need more time for you. We have still have got 3 chapters and I need more time so that because in essay 2, we will be using or taking um, FA3 and FA4 portion as well. Remember. Got it?
Okay, ma'am.
I need more time for explanation, more time for discussion, more time for making you understand. You understand?
Yes.
Do you allow me to use this 15 minutes for the new chapter?
Yes,
Yes,
ma'am.
ma'am.
As you
Of
wish. Yes,
course.
ma'am.
We start with a new chapter. That's lesson number 16, light.
Light.
Okay? You find it, this also is very simple. It's all up to you, better. The way you take it. If you take it difficult, then it will be difficult for you. If you think that yes, I want to learn something new, it's a new chapter altogether, and I wish to learn a maximum as much as possible, then things become very easy. What do you say? It's totally in your
Yes.
brain. It's totally your
Yes.
perception. The way you take, it becomes the same. Okay. Now what do you find over here, Peter? What do you see?
Reflection of light.
Reflection of light.
Okay, you see reflection, but I see a beautiful picture. What do you say?
Yes.
It is a beautiful
Yes.
picture. It's of Alaska. It's of Alaska. Can you see this? The reflection? You see the reflection?
Yes.
Yes.
Yes. Beautiful picture. So this is the reflection. How we see things. Can anyone explain, if possible?
From our, because we have eyes.
We have eyes. Fine. One side we have eyes. Okay. We have eyes. I agree. But if I put you in a dark room, what your eye will do?
Can't see.
Second, you believe that. So what is more important? What is more important?
Light.
Light, exactly. So what is important? Light. All of you agree? All of you agree?
Yes. Yes.
Make things visible.
Yes.
Light is must. What did I say? To make things visible, light is a must. Understood, beta?
Yes, ma'am.
Yes,
And
ma'am.
this is incident ray. What is this ray, beta? Incident
Incident
ray.
ray.
This is torch. It is giving the incident ray. This is a mirror. Yes or no? This is a mirror.
Yes.
It is falling here, then it gets reflected. You agree? So this is reflected ray. What ray it is, beta? Reflected ray.
Reflected ray.
Where it goes? It goes in the eye. Yes or no?
Yes.
It goes in
Yes.
the eye. From eye, it goes in the retina. Where does it go? Behind the eye. It is not retina. Say retina.
Retina.
Where the image is
Retina.
formed. Where the image is formed. From there, it goes to brain, and the brain registers. Hope you have understood
Yes.
how the things are happening. Now you understood better.
Yes.
Yes,
But
ma'am.
eye, no doubt about it. Eye is important. Otherwise, we'll be called blind, isn't it? But
Yes.
if eyes cannot see, do you think the things will be visible? The object will be visible? No. So I need
No.
a source of light. I need a source of light. So what is important? Reflection. What is important?
Reflection.
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 If it is not reflected, I cannot see anything. So the light has to be reflected by the object, then only I can see the object. If reflection is not there, I cannot see the object. Is it clear?
Yes, ma'am.
Yes.
All of you understood? All of you understood? So what is important? What is important?
Reflection.
Reflection. Without reflection, you cannot see visible things. Now see how reflection of light takes place. Please read better.
Reflection of light. What makes thing visible? When light falls upon or is emitted by an object, our eyes detect that light and hence the object becomes visible to us.
How the things are visible to us. We are looking around, we can see things. How is it possible? Because the light is falling on them. I see trees, sun rays are falling on it, so I can see trees. Or an object is emitting light. For example, the bulb at your place, the candle at your place, the gas stove at your place. Yes, it
Action.
is emitting their own light. You understood now? Emission and reflection, did you get the difference? Emission means their own light. Reflection means the light is somewhere else and they are reflecting and so it is visible. What is happening? Our eyes is detecting that light which falls on the object and then it gets reflected to our eye. So that object becomes visible to us. Is there any problem?
I don't
Until
think.
unless there is no reflection, we will not be able to see the object. Is it clear?
Yes.
Is it clear? Girls, so reflection is a must for making the object visible to our eyes. Otherwise, we cannot see the object. Reflection is a must. If no reflection, we cannot see the object. May be there, but we cannot see the object if there is no reflection. Is it clear? All of you? All of you, beta?
Yes, ma'am.
Okay. Now look over here. What is this energy?
Light.
It is light energy. Energy is giving light, beta. So which is that energy which is giving light?
Electromagnetic
It is electrical energy. What is it?
Electrical energy.
energy.
Because we are switching on the light, isn't it? We are switching on the electricity. So that is electrical energy. And by that, the bulb glows. Yes or no? So this energy is transferred to which energy, beta? Heat energy and light energy. Yes or no? Heat plus light energy. Agree?
Yes.
Hello. Okay. Now this light is in the form of electromagnetic radiation. You agree?
Yes.
Yes. So this radiation is observed by what? Eye. What eye has? Eye has photoreceptors. What eye has, beta? Photoreceptors. What is photo?
Photoreceptors.
Photo.
What is photo? Photons are light. Receptors are the cells which receive it. You got it now? So
Yes.
eyes have got photoreceptor cells which receive the light and it goes to the brain. It goes to the brain,
Brain.
which registers what you have seen and which color is it. Is it clear?
Yes.
Yes.
Read.
Light scatters as goes. Light scatters and loses energy the further away from its source.
Okay, take a torch. I'm asking you better. Take a torch and you switch it on. What will happen? The light near the torch will be bright and the light which is away from the torch will be a bit faint. Yes or no?
Yes.
Yes.
What does that mean? It is losing energy.
Yes.
Yes.
Understood or no? So when we are going further away from the source of light, the energy is lost. For example, when I'm near you can say table lamp. I'm talking about table lamp which is on the table. So you feel the heat of the table lamp, isn't it? But when you go away, you don't feel the heat nor you feel the powerful light, isn't it? It becomes a bit faded. What do you say?
Ma'am, I don't understand.
Who is that who said I don't understand? Shiva?
Shifa.
Shifa? Delisha, did you
Yes, ma'am.
understand? Who understood? Tell me first. Who understood what I said just now? Delisha, did you understand?
Ma'am, like half.
Doesn't matter. Try. Say, I'm there to help you out.
Means near means when
Near the source.
yeah, near the source light is more, and
And you can feel the effect of it.
if we will go
As away from the
away
source
from its source, it will like
becomes,
light is less.
yes. So it faints. It fades away. Yes. Shiva, did
Yes.
you understand?
Yes, ma'am.
That's all. I was trying to give examples and make you understand, but this is all simple. Take torch or take headlight. Okay, let's take headlamps of your car. At night you put it on, isn't it? But when it is nearby, on the road, near the headlamp, the road becomes very clear. But away from the headlamp, it is a bit faint. Yes or no?
Yes.
Yes.
That's it. The same thing. Any problem? For
No, ma'am.
example, look over here. Here it will be very bright, but here it will be a faint. Yes or no? That is what
Yes.
I'm telling you. Okay? Okay, what is light?
What is light?
Read better.
Light is the part of the AM spect-
Electromagnetic.
electromagnetic spectrum
Electromagnetic.
electromagnetic spectrum which we can see. Light travels in straight lines called rays. A bundle of rays is known as a beam of light.
So what we know light as electromagnetic spectrum, isn't it? The sun rays that it is coming on the earth. This is electromagnetic spectrum. It travels in straight lines. We know that, isn't it? Do you know that light travels in straight lines?
Yes.
Yes, I think taught you once in seventh standard maybe that if I
Yes.
take this as a candle, yes, and we will take a pipe like this, and this is your eye, yes, this is your eye, got it? This is your eye. So you're observing the candle through this pipe, and you can see. But if I make the pipe bent, will you be able to see the candle?
No.
So that shows that light travels in a straight line. Okay, all of you understood better? Now this
Yes.
is called as ray. Can you see this? This is called a ray. When parallel rays come together, it becomes beam of light. What it becomes, beta?
Beam
Beam
of
of
Beam
light.
of light. So I'm just making you understand all these terminologies. Now here you can see from one source it is going to so many areas. This is called as divergent. What it is called?
Divergent.
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 And from far it is coming to one point. It is focus that is called as convergent.
Convergent.
Understood now?
Yes.
Understood? Okay. See again, reflection. Read it. Maybe this is going to be the last
Yes.
slide. Read better.
Reflection, light that bounces off an object like a mirror or shiny materials. Mirror reflect light at the same angle that the light strikes them. This works the same this works the same way as a ball bouncing off from a flat surface.
Okay. Now you see a ball. Now the ball bounces. It goes here and then bounces back. You understand now? Now if I try to show you the angle that it makes is same. This angle and this angle is same. Agree? Agree or not?
Yes.
Yes? Okay. Same way, light also bounces off. Now if this is a mirror or shiny material, the light falls here. The same angle it goes back. You understand now?
Yes.
You understood now? So mirror reflects light at the same angle that the light strikes them here. So this angle becomes this angle. So what we understand? Angle I is equal to angle R. Understood? Angle of
Yes.
incidence is equal to angle of reflection. All of you understood better?
Yes, ma'am.
Okay. Should we stop it? Or there's
Yes, ma'am.
1 minute? How much time is left?
Ma'am, 10:15 done.
It's
But
already
we
done.
can
Okay.
complete this slide, no, ma'am?
Okay, no problem. As you wish, better. Read
Okay.
then.
Reflection. Reflection is the bouncing of light rays off a surface. We are able to see non luminous objects as light is reflected off them.